Hi friends, today I am giving a lecture on representation of signed numbers. Before going to the representation of signed numbers, first of all, what is signed numbers and what is unsigned numbers? That we have discussed. Okay, suppose we are taking the number 41. Before that number we have to put the positive sign. So because of this positive sign, this number is called as positive number. Okay, 41 is a positive number. Okay, now consider this number. Before the number 41 we have to put the sign, negative sign. Okay, because of this sign we can say that 41 is a negative number. Okay, here we have to put the sign symbol, either it is a positive symbol or it is a negative symbol before the number. That number is called as signed number. Okay, so here in the same way, here 9 is the digit. Before the digit we have to put the sign symbol plus. Because of this symbol plus, this number is a positive number. Okay, here before the digit 9 we have to put the symbol, negative symbol, that is minus. Because of this symbol we can say that 9 is a minus 9 is a negative number. Okay, so what is a signed number? So before the number we have to put either positive symbol plus or negative symbol minus. Then we can say that that type of number is called as a signed number. Okay, before the number we do not put any either positive symbol plus or negative symbol minus. That type of number is called as unsigned number. Unsigned number does not have any positive symbol plus or negative symbol minus. Only signed numbers have the symbol plus or minus before the number. Now we go for representation of signed numbers. There are three ways of representing signed numbers. One is sign magnitude form, second one is 1's complement form, third one is 2's complement form. By using these three representations we are representing the signed numbers. Okay, first one is sign magnitude form. Sign magnitude form is the primary method of representation of signed numbers in terms of binary data. Okay, so among the three representation, the first representation is the sign magnitude representation. By using this representation we have represent the signed numbers in terms of binary data. Okay, next one, suppose if the given number is a positive number, we have to put the digit 0 at the MSB position followed by the binary number. Suppose if the given number is a negative number, then we have to put the digit 1 at the MSB position followed by the binary number. So for example, here plus 9 is there. Okay, so here before the number the sign symbol is plus. So because of this symbol, this number is a positive number. Okay, now because if the number is a positive number, we have to put the digit 0 at the MSB position. Here this is the MSB position and this is the LSB position. At the MSB position we have to put the 0 as a sign bit. Okay, followed by the followed by the normal binary number. So 9 can be represented as 1001 as a binary number. Okay, this is a 8-bit register. So 0 to 7, last 7th bit is the MSB bit. At the MSB bit, we have to put the 0 bit. 0 bit is called as a sign bit. Because of this sign bit 0, we have to say that the given number is a positive number. The remaining 7 bits represents the magnitude. So here 9 can be represented as in the binary form 1001. Here up to this one is the binary form. This is the sign bit. The remaining bits are filled with zeros. Okay. So this is the sign bit and the remaining 7 bits represents the magnitude. Okay. In the sign magnitude form, okay, it contains 2 parts. The first part is called as sign bit position. So sign bit position always represented at the MSB bit position. The remaining bits represents the magnitude of that given number. Okay. Next one, here -9. Here the number is a negative number. Okay. Whenever the given number is a negative number, we have to put the digit 1 at the MSB position. At the MSB position, followed by the normal binary number. So 9 can be decimal 9 can be represented as 1001 in the binary form. Here negative sign is there. To represent that negative number, we have to put digit 1 at the MSB position, and the remaining bits are filled with zeros except 1001 and sign bit. Okay. Next one, +41. Here it is a positive number. To represent the positive number, we have to put the digit 0 at the MSB position. The remaining bits represents the magnitude. So magnitude 41 can be represented in the binary form 101001. Okay, here 6 bits represents the magnitude and 1 bit is a sign bit. The remaining bit is filled with a 0. Okay, the binary form can be starts with the LSB position. Okay, next one, -41. So -41, this is a negative number. We have to put digit 1 at the MSB bit position, followed by the normal binary number. Here 41 can be written as 101001 in the binary form. This is a 6 bit and 1 bit is a sign bit. The remaining bit is filled with 0. Okay, the binary form of 41 can be written from LSB position. Okay, 6 bits represents the magnitude and 1 bit represents the sign bit. The remaining bit is filled with 0 because to represent this signed numbers, we have to use 8-bit register. Okay, so after representing the given number in the binary form, if any vacant cell is there, that vacant cell is filled with zeros. Okay, so this is the sign magnitude form. Okay. Now, what are the advantages and disadvantages of sign magnitude representation? Advantages are, it is very simple to understand. It is most fruitful representation. Okay. While coming to the disadvantages, whenever we have to perform addition and subtraction operations, we will consider both sign bits as well as their magnitudes. Okay, so that means whenever we have to perform addition operation we will consider both sign bits as well as magnitudes of the number. Okay, so this is one disadvantage. The second disadvantage in sign magnitude representation is there are two representations for a single digit 0. Okay, it is a positive 0 or it is a negative 0. But 0 plus 0 and minus 0, which is not acceptable. Okay, plus 0, this value is 0. Minus 0, this value is also 0. Okay, so here in sign magnitude representation, we have to represent 0 in sign magnitude form. We have to use two representations, that is the plus 0 and minus 0. But plus 0 or minus 0, its magnitude is always 0. But there are two representations in sign magnitude which is not acceptable. Okay, so here in the case of plus 0, we have to put 0 at the MSB position as a sign bit followed by the magnitude of this number in binary form. Okay, whereas in the case of negative 0, minus 0, we have to put digit 1 at the MSB position as a sign bit followed by the magnitude in binary form. Okay, here 0 is always 0. To represent 0, we have to use plus 0 and minus 0. Okay, there are two representations for 0, but so there is no negative 0, there is no positive 0. Okay, 0 is always 0. To represent that 0 value, we have to use two representations, plus 0 and minus 0, which is not acceptable. This is another disadvantage in sign magnitude form. Okay, now going to second representation, signed 1's complement representation. Okay, in order to represent the given signed number in terms of signed 1's complement representation, by changing the magnitude of that number from 1 to 0 and 0 to 1, there will be no change in the sign bit. Okay, so this is the followed in sign 1's complement representation. Okay, so for example, so now we have to represent decimal 9 and 10 in terms of signed 1's complement representation by using 8-bit register. So here plus 9 can be represented as 9 can be represented in binary form 1001. Okay, here positive sign is there. We have to put a 0 at the MSB position. Total 8-bit register, how many number of bits are there? Up to now, this is 4 and this is 1, 5 bits. The remaining 3 bits are filled with 0. Okay, so in this way, we have to represent plus 9 in 8-bit register. Now, plus 9 can be represented in signed 1's complement representation. There will be no change in the sign bit. Okay, plus 0 at the MSB position, sign bit is 0 because the value is plus 9. Okay, so there will be no change in sign bit. So there will be no change in sign bit. The remaining bits, that means magnitude, that magnitude can be changed from 0 to 1 and 1 to 0. If it is 0 is there, it can be replaced by 1. If it is 0, it can be replaced by 1. If it is 0, it can be replaced by 1. Here the bit is 1, it can be replaced by 0. Here the bit is 0, it can be replaced by 1. Here the bit is 0, it can be replaced by 1. Here the bit is 1, it can be replaced by 0. Okay, so this is plus 9 can be represented in sign magnitude representation. Okay, so this sign magnitude representation can be converted into signed ones complement representation. Okay, here we have to change two changes. Here the first one is there is no change in sign bit. So here the sign bit is 0. Here also sign bit is 0. So the remaining bits in magnitude changes from 1 to 0 and 0 to 1. If the bit is 0, it can be changed to 1. If the bit is 1, it can be changed to 0. Now the result is 1's complement representation of plus 9. Here this is the representation 0, 111, 0, 110. Okay, in this way we have to represent the signed ones complement representation of plus 9. Okay, whereas minus 9 can be represented here, the negative sign is there, sign bit is 1. Okay, the remaining bits that represents magnitude is same, 111, 0, 110. Okay, here plus 9 minus 9. Okay, here what is the difference? Only sign bit is different. The remaining magnitude is the same. Here plus 9, the sign bit is 0. Here minus 9, the sign bit is 1. But magnitude, there is no change in magnitude. Here 9 is there, here 9 is there. There is no change in magnitude. Only difference is in sign bit. Here plus 9, here we have to put digit 0 at MSB position as a sign bit. Here minus 9, here we have to put digit 1 at MSB position as a sign bit. Okay, now plus 10. Okay, plus 10 can be represented as, so here 1010 is the binary form of 10. Here plus sign is there, the sign bit is 0. So total 5 bits are there. It is 8-bit register. The remaining 3 bits are filled with zeros. Okay, so this is plus 10. Okay, plus 10. Now, so this is sign magnitude representation. It can be converted into ones complement representation. Sign bit, there is no change in sign bit. The remaining bits in magnitude, so change 0 bit to 1 and 1 bit to 0. Here 3 zeros are there. 3 zeros can be converted into 3 ones and 1 can be converted into 0. 0 can be converted into 1. 1 can be converted into 0. 0 can be converted into 1. Okay, so this is the signed representation of plus 10. This is the ones complement representation of plus 10. Here 0, 111, 0101. Okay, so this is a plus 10 can be represented in ones complement representation. Okay, minus 10, only sign is different but magnitude is the same. So here plus 10, so sign bit is 0 at the MSB position. Here minus 10, so here sign bit is 1 at the MSB position. Here magnitude is the same. So the magnitude is 1110101, 1110101. Okay, so this is the signed ones complement representation. Okay, the previous one is signed magnitude representation. The next one is signed ones complement representation. Now we go for signed 2's complement representation. Next, the third representation is signed 2's complement representation. It is the most widely used signed representation. Okay, signed 2's complement representation is the most widely used representation for representing the signed numbers. Okay, to represent the given signed number in signed 2's complement representation, the magnitude of the given signed number can be represented in 2's complement form. 2's complement form can be obtained by 1's complement form plus a 1. There will be no change in the sign bit. It is the same as in 1's complement representation. Okay, here we have to use two changes. First one is there will be no change in the sign bit. Second one is the magnitude of the given signed binary number can be represented in signed 2's complement representation. Signed 2's complement representation can be obtained by 1's complement representation of the given signed binary number plus a 1. This 1 can be added at the LSB position. Second one is there will be no change in the sign bit position. Okay, now consider the decimal representation, decimal values plus 10 or minus 10, plus 9 and minus 9 can be represented in 2's complement form. Okay, so now consider plus 9. So plus 9 can be represented in sign magnitude form. So here positive sign is there. Here we have to put 0 at the MSB position as a sign bit. Next one, 9 can be represented in binary form 1001. So it is we have to use 8-bit register. In that one we have to put 8 bits. Here there are 4 bits are there and 1 bit is a sign bit. So there are total 5 bits. The remaining 3 bits can be represented as zeros. Okay, so the binary form can be represented from LSB position. Okay, so this is a sign magnitude representation of plus 9. Now signed 1's complement representation of plus 9 can be obtained. So there will be no change in sign bit because plus 9, this is a positive 9. So to represent the positive number we have to put 0 at the MSB position as a sign bit. The remaining bits in the magnitude can be changed from 0 to 1 and 1 to 0. Here 0 is there, here we have to put 1. Here 0 is there, 0 can be replaced as 1. Here 0 is there, 0 can be replaced as 1. 1 is there, 1 can be converted into 0. 0 can be converted into 1. 0 can be converted into 1. 1 can be converted into 0. This is the signed 1's complement representation. This is the signed magnitude form representation. Now, how we are getting the signed 2's complement representation of plus 9? So there will be no change in the sign bit. So here plus 9 is there. So here we have to put 0 at the MSB position as a sign bit. The remaining magnitude, for that magnitude we have to add a 1 at the LSB position. Here LSB position is this position. Here we have to add plus 1 because signed 2's complement form is equal to signed 1's complement form plus 1. Okay, this 1 can be added at the LSB position. Now 0 plus 1, that is 1. The remaining bits are same. Okay, so 2's complement is equal to 1's complement plus 1. This 1 can be added at the LSB position. So this is the signed 2's complement representation of plus 9. So now the answer is 0. Next, 3 ones, 1, 1, 1. Next one, 0, triple 1. Okay, so this is the signed 2's complement representation of plus 9. Okay, here minus 9 is there. So the magnitude is the same. Okay, and sign bit is 1 because here negative sign is there. To represent the negative number, we have to put sign bit as 1 at MSB position. Okay, this is the sign bit. This is the sign bit. Okay, and this is the magnitude. And this is also magnitude. And this is also sign bit. Next. Now represent 10 in sign magnitude form and sign 1's complement form and sign 2's complement form. Okay. Here, what is the binary form of 10? That is 10, 10. Here, plus symbol is there. We have to put 0 at the MSB position as a sign bit. So there are 4 bits and this is 1 bit. 4 plus 1, 5 bits. So this representation is in 8-bit register. So the remaining 3 bits we have to put as zeros. Okay, so this is the sign magnitude representation of plus 10. Okay, now sign 1's complement representation of plus 10 is there will be no change in the sign bit position. Only the magnitude can be changed from 0 bit to 1 bit and 1 bit to 0. Here 0 is there, 0 is converted into 1, 0 is converted into 1, 0 is converted into 1, 1 can be converted into 0, 0 can be converted into 1, 1 can be converted into 0, 0 can be converted into 1. So this is the signed 1's complement representation of plus 10. Okay. Now signed 2's complement representation of plus 10 can be obtained by signed 1's complement representation plus 1. This plus 1 can be added at the LSB position. Here 1 is there at the LSB position. We have to add plus 1. Okay. Now 1 plus 1. So that is 0 with the carry 1. So 1 plus 1, 0 with carry 1. Here 0 plus carry 1, that is 1. The remaining bits are same. Okay. Here there will be no change in the sign bit. Okay. So here sign bit is 0. The magnitude in 1's complement representation plus 1, we are getting the signed 2's complement representation. Okay. So now plus 10 can be represented as sign bit is 0. The remaining bits are triple 1, 0, 1, 1, 0, 0, 1, 1, 0. So this is magnitude and this is sign bit. Okay. Now minus 10 can be represented in signed 2's complement representation. So only the magnitude is the same and sign bit can be changed from 0 to 1 because here negative sign is there. Negative sign can be to represent the negative number. We have to put digit 1 at the MSB position as a sign bit. So this is LSB and this is MSB. So this is LSB and this is MSB. This is LSB and this is MSP. So this is sign bit and this is magnitude. Okay, so this is the description about representation of signed numbers. We have to use three representations. One is signed magnitude representation, second one is a signed ones complement representation, and third one is signed twos complement representation. How we are representing the decimal numbers either in positive number or in negative number. So how we are representing the positive numbers in signed magnitude representation, signed ones complement representation, signed twos complement representation. How we are representing the negative numbers in signed magnitude representation, signed ones complement representation, signed twos complement representations. With examples we are already discussed. So thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Dibbela Srinivasarao. Dibbela Srinivasarao. Thank you.